Okay, hello everyone. Welcome to Google Developers Space channel, and thank you for tuning in to the live stream this evening. Yeah, so for today's session, we're very excited to be hosting our new community partner, Data Engineering Singapore. So welcome Teck Chun and Ravindra. So they'll be bringing a lot of good data engineering content to the community. So please stay tuned. Yeah, so before we begin, right, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups around the region to learn, connect, engage, and be inspired. So I'm Lawrence from Google Developer Relations team. So as part of the team, we aim to empower and connect the community to our people, programs, network, and technologies, be in person or online like today. So yeah, I believe you will have questions for the speaker later on. So if you have questions, so please put in the comment section and we will answer them accordingly. Yeah. So without further ado, I will hand the stage over to Tikchu and Ravindra to start today's session. Over to you guys.
Okay, thank you, Lawrence, and thank you, Google Developer Space for hosting us. So we're going to partner with Google to host this series of meetups for bringing you the contents, right? And with me is my co-organizer, Ravindra. Ravindra, I want to introduce a bit about yourself.
Hi, I'm Ravindra. I'm having about 15 years of experience in data engineering. So I started my career as a developer, then worked a couple of years in DevOps side, and then finally moved in data engineering side. And since then, I'm working on it. And currently, I'm working in Data Spark and working under Techshun. So he's my head of engineering and who leads different departments in Data Spark. Yeah.
All right. Yeah, thank you, Ravindra, for the intro. Yeah, my name is Teck Chun. Yes, I work with Ravindra a lot on data engineering matters. So a bit about Data Engineering Singapore. So we started this group to sort of cultivate and gather like-minded individuals who are interested in all things data engineering, right? Including extraction from curation to how to move data, data quality, and everything around data movement and curation and quality, right? And also transformation and every other tooling and platforms that enable us to do our job easier. So today we have one speaker. Without further ado, maybe we can bring on Adrian. Yeah. Hello, Adrian.
Hello.
Hi.
Hi.
Yeah.
Hi. How are you
Hello.
guys?
Hi. Yeah. Good. Adrian is from Snowflake. Maybe just a bit of intro. So Adrian, you want to give us a short introduction about yourself and your journey on data engineering to date? Yeah.
Yeah. Sure. Thanks very much, Teck Chun and Ravindra for actually having me on this session. I'm actually a solutions engineer at Snowflake. I've been there. I just joined like last year. Before that, I was actually in the cloud native app space, and how I got all interested in data engineering was that actually previously I was already in data, as well as building cloud native apps, right? And then after it just so happened that I had the chance at Snowflake to actually build out the warehousing. Advocating Snowflake as well as building up the platform, especially for data engineering workloads. So that is kind of like my background of actually how everything came to be so far. Yeah.
Okay.
Right.
Okay. Thanks for the intro. And Adrian, I want to introduce a bit about today's talk, just a brief description, and what drove you to want to present this topic today. Yeah.
Sure. So I think the idea here is that today's session will be actually mainly about database change management and DevOps, and basically it's actually surrounding the concept about how do we actually introduce change management on timeline for database and implement DevOps principles to it. Because now, as everyone knows, everything is more or less going to public cloud, right? And the idea here is that gone are the days like, for example, how do we do traditional extraction, transformation, and load? Now, the focus more is like, for example, how do we do ELT models instead of ETL? And the whole concept about that is actually how do we introduce these changes, right, alongside with different tool sets, open source tool sets to build out efficient pipelines. So that was my interest all along. I've been doing it, and then after that later, got this opportunity to share. So thanks very much, Teck Chun and Ravindra. So yeah, that's how it is.
Okay.
Yeah.
Okay, thanks for that, Adrian. So not to hold you back, I know you got a very enriching and very interesting content to share. And for guys tuning in on YouTube, please type in your questions on the YouTube channel, comments itself, and we will answer them at the end of the session. Right. So over to you,
Okay.
Adrian.
Thanks, Nick Chun. Can everyone see my screen? I mean, is it presentable? Okay. So
Yes.
it's okay, right? All right. So I think the idea here, maybe I'll just walk through the rough agenda, right? The agenda for today, right? Probably I'll be spending about maybe 40 to 45 minutes on slides, right? And then after 15 minutes to go through a very quick demo. The idea here is that what we're going to talk about today mainly is about database, as the topic suggests, is database change management and DevOps. Okay. So I think everyone has been actually pretty excited, especially in the DevOps space. We have learned a lot of things like continuous delivery, CI/CD, build agent, agile, continuous integration with Git, Jenkins, so on and so forth. These all these cool terminologies. And I think a lot of it actually has come into mainly the application modernization space. Like for example, how do we introduce continuous delivery right into my applications? How do I do continuous deployments for my applications? But then we always lack, or we always tend to forget, what about the database change management portion? How do we actually manage that sector, right? Our applications are great. We can push out new applications, but we cannot forget about the database portion. We cannot forget about, especially on the warehousing portion as well. So why does database DevOps actually matter? So what happens is that it actually introduces quite a few benefits. And with the rise of public cloud, right, as well as the tool sets surrounding the public cloud, it actually helps to support agile software development, especially for data engineering. So some typical benefits, right, is that there's immediate value to business. Like for example, with actually DevOps implementations, right, into the database management, we're able to see the real-time changes of what's happening in the database to our application. The other thing is that business actually changes. There's actually new requirements every day, right? So how do we actually integrate these pipelines together to make it actually more efficient? It also helps to eliminate and reduce recurring manual tasks. I think everyone knows that actually doing things manually, right? Like for example, I go and manually change a schema or manually change something to actually adjust my database to be in line with my application, right? It's a very manual and it's very error prone. We always heard of fat finger errors. So this actually helps to mitigate that issue. Of course, the other portion is automated testing. So we're able to actually create fluent pipelines, right? With let's say test changes to actually test our changes in our databases and our data warehouses to make sure that whatever tests that or deployments that we're making into our dev UAT or even to production, right, it actually helps to fit into the application and database portion. Naturally, the last few points will be actually it helps to coordinate large development efforts. It also helps to establish consistent delivery schedules, and it delivers a high quality data product, especially. So I just want to direct your attention just onto the right. We can see that actually with application modernization, right, there's a lot of uptake. You can see there's 85% using like version control, 64% using monitoring, 64% using automated build. But you can see that actually the database pickup in terms of practices also, it is slowly picking up. And this was a source of actually from 2021 by State of Databases DevOps by Bitgate. Yeah. So we can see that definitely with the paradigm shift in DevOps engineering and agile software development, it also has actually brought in new paradigms, especially for data engineering. Okay, so I think maybe before I go into the nuts and bolts, right, I think I want to address some challenges with database DevOps. Database DevOps, especially for data engineering, is difficult, right, and it has challenges, especially like, for example, the state. If your application code is stateless, like for example, it actually introduces this challenge with how do we integrate the incremental changes from your database back into your application code. Database contains like valuable business data, changes in structure. There's also the concept of downtime. Applications are easy to actually swap out, but how do we actually swap out a database server? It's difficult to swap out a database server, especially in a cluster sometimes. Of course, you can use like Oracle RAC clustering, for example, for instance. But right now, traditionally, now currently in the new, like how we do things, right? Like it's actually difficult to swap out databases or tables in and out seamlessly. Rollback, right? Applications are easy to roll back. Let's say I have a Git control, right? With a Git SVN, I can easily roll back to actually a source control. But then for databases, on the other hand, you need to, let's say you're using the OLTP databases, you need to explicitly back up and restore those databases, which is very time consuming, which may not make sense as well. Even when you're actually on the public cloud, for example, some databases, you need to actually manage some of the backups. Also, the database is unavailable during the restore. Testing. Application code is easy with unit testing, but unit testing for databases is a bit more challenging in this aspect, and you need actually a quick test generation or demand management, which can get complicated quite quickly. Now, the last part is especially on traditional, only DBAs know how to modify the databases. What database don't match the source control, there's a compatibility drift. Also, the specific topic maybe that we want to talk about today is database change management is difficult, especially in the arena of database DevOps. So currently, there are actually two approaches to how do we implement database change management or database schema migration or schema change management. Right? There are two kinds of approaches. One is declarative, and one is imperative. Now, the one on the left is imperative. So imperative, right, as what it is actually declared, what it is actually meant by it, right, is that you have a series of change scripts. You actually version the change scripts. There are pros and cons to it. It's very, very flexible, like in the sense that you have different versionings, right? You know how to keep track of it. But sometimes it's also, especially if you have too much versioning, right, it may be also cumbersome and you may be exposed to errors. And also you need to maintain the state and version of each database. So that's the imperative approach. And I'll be going through some actually tool sets later that is actually happening in the ecosystems, right? Of course, both the imperative and declarative states, right? So that you know what kind of tool sets are out there. Whereas, so coming back to this, right? Declarative, on the other hand, right, is very specifically, like, for example, I as the name suggests, I declare a state. This is the end state that I want to actually get to. And I don't care how the tool does it, it actually helps me achieve it, right? So in essence, it's like a single definition of objects, great for development. It's definitely less error prone because you do not need to create multiple versions which don't make sense. And then update later, you can just use a declarative approach to do it. Okay, so going on to my next slide. Source control naming differences. So this is again coming to this, right? Like imperative, you can see that we have different versioning, which also I was talking about just now. We have different major versions. We have different first changes or second changes, third changes, and we need to actually name it all consistently or for your benefit, so you do not actually have a fat finger error on the second day, for instance. You need to arrange the change scripts to match your SDLC process. Try and follow the declarative folder approach and include your user story in the file name. So you can see, like, for example, in this file structure, I have v111.12345 first change, and then v1.2.1 1, 2, 3, 4, 6 second change, and then third change, so on and so forth. So that's the imperative method approach. The right, on the other hand, as you can see, is just the declarative. I just need to declare my state inside the full.sql file, and it will actually help me to achieve that state that I want. Okay, so actually the imperative and declarative tooling, right, is not uncommon. I mean, in the application modernization world, this is something that has been going on for quite a while as well in terms of imperative and declarative tool sets. We're just now applying those tool sets, especially for database and data warehouse management. So let's look very more specifically at imperative tool sets. And I'm going to talk about data warehouses, right? Because I'm from Snowflake. Naturally, I've been dealing with data warehouse. And I think a key thing here in terms of the imperative tool sets for data warehouse is, like, for example, there are tool sets such as Flyway, Schema Change, Liquid Base, Gauge, and SQL Alchemy. All right, like, for example, both of them are in different, like, you can see the tool sets, right? They're in different languages. Like, for example, Flyway was developed in Java. The scripting language is mainly using SQL. There's some pros and cons, which I'll just go over briefly. I won't go too in depth, but definitely if you want to experiment and see these tools, you can Google it and see how it works. So, like, for example, Flyway and Schema Change. Flyway is actually pretty mature. It has been around for quite a while. I think maybe in 2013 and 2014. Yeah, I can't remember the exact date. But in terms of Flyway, it is definitely matured. It's a very lightweight and flexible naming, right? Freemium model. You can do dry runs, undo the cost, and other features. And Schema Change was actually built on top of actually Flyway. It's very similar to Flyway, open source, and it's actually being used primarily for database change management for, let's say, Snowflake. Of course, here then you have your other DCM tools like Liquid Base. is much older, right? I seldom see liquid base being used. Sketch as well, right, is written in Perl. You need definitely a container for doing CI/CD, and there's dependencies in the config file. And then you have SQL Alchemy, right, that actually helps you to write migration scripts inside the Python. May not be desirable for you to do that. Okay, so these are the imperative kind of tool sets that we have for database change management. And then we have the declarative tool sets for data warehouse. And I think everyone knows, not sure if everyone knows, but Telform is a great example of a declarative tool set, right? For those who do not know, right, Telform actually came onto this, is actually developed by this company called HashiCorp. And essentially what happens is that with the rise of public cloud, right, Telform was actually being deployed for using infrastructure automation across multiple clouds. Okay, so you can use it to actually help to automate your infrastructure or even your application to some extent, depending on how your application is being built. But you definitely can use Telform to actually help to automate certain things. And basically, there are actually plugins that are being developed on top of it. So I think what happens is that in like Snowflake, there's an open source provider for Telform for Snowflake that was developed by Chan Zuckerberg. And essentially, this is actually supported for all objects. Like, for example, I have like table object, okay, not table object, sorry, database object, things like account usage, usage of rows, so on and so forth. But it's not good for actually, like, for example, table data change management. I can use it to do a primarily setup of my environment, okay, which we'll be exploring in the models later. There are different models, and one of the models that we'll be looking at, right, is how do we integrate Telform inside my DCM environment. And essentially for here, right, Telform is great, as mentioned, for initial setup. Day 2, day 3, it depends, because, like, for example, unless you're really familiar with how to manage the Telform infrastructure, especially the state file changes, right, it may be a bit troublesome for you, yeah, realistically speaking. And I think one of the better tools that actually have come up to date recently is something called DBT. So DBT is actually a data transformation tool. And what happens is that it's making the paradigm shift from ETL to ELT. And essentially, it works with actually really good data warehouses out there, like Snowflake, of course, with like GCP BigQuery. Yeah. So what primarily does, right, is that it's a data transformation tool. And essentially what happens is that you write it mainly in using Jinja and SQL, and you let actually DBT handle it for you in terms of the custom materializations to manage objects, like your tables, your views, materialized views, so on and so forth. So what happens is that DBT realized that with the increase of public cloud warehousing, data warehousing, slowly they are actually leveraging the compute of actually the warehouses, right, to do these transformations. That's how they're becoming pretty popular, especially in the data engineering and data transformation ecosystem. Okay. So let's talk about some possible patterns, all right, especially in terms of architecture patterns. Now, different kinds of architecture patterns that are being deployed in terms of how do you do data engineering with DCM. Okay. So namely here, what I'll be talking about is some of the models which I have experienced and how I look at it. Right, and I want to be upfront as well. Not every model fits for every organization. It kind of depends what your strategy is. Then we can see what is the according methodology that do it for you. So, like for example, model 1, we use a single imperative DCM tool. Model 2, we do imperative DCM with SCIM and permission management, for example. Anyway, right, just also as of that, these models that we're looking today, of course, I'm making relations to, of course, Snowflake data warehousing, but if you need translate it to the corresponding terms with regards to the other data warehouses. But specifically, we're looking at how to manage these models. Right. Model 3 is like, for example, imperative DCM, which actually with SCIM, DBT, and as well as permission management. And model 4, right, is using Telform, imperative DCM, and as well as DBT. Okay. So without further ado, let's jump into these models, right, to actually try and understand it better, what's exactly happening. Now, what happens is that on the right, this is what are all your kind of like typical database objects. Like inside, say in Snowflake, right, we have user, we have warehouses, table, tasks, stages, roles, resource monitors, so on and so forth, right? Now, what happens is that I have divided it as accordingly, right? The dark blue ones are account level objects. These are things like your users' roles, grants. Like for example, how do I create a role? How do I grant this role to a user? How do I actually integrate, like for example, how do I have a virtual warehouse compute? what kind of databases do I have? Resource monitoring, how do I monitor my database objects, right? And the one on the right, the light blue colored one, are actually schema level objects. So certain schema level objects are definitely things like table, external tables, user-defined functions, stored procedures, stages, pipes, streams, sequences. So these are all the concept of actually schema level objects. Now you can see that in the right-hand corner, I have schema change there, which is the imperative DCM tool. Easiest way to start. So if you do not know really where to start off with, this is really the easiest way to start off. Using schema change, you can actually do it. But some things that I probably just want to highlight, the issues noted here. Managing schema change is great at managing like incremental schema level objects, but the thing here is that like account level objects, it wasn't meant really for it. The idea of actually managing users and roles and grants using traditional DCM is troublesome. So that's where we actually integrate, or that's where we look at maybe, okay, how about for management of users, right? Why not we integrate it with an enterprise IDP, or we use an IDP like, let's say, Okta, SCIM to manage those users. And as well as how do we manage the grants? How do we manage, like, for example, what kind of grants are being given to a particular user for a particular role? So we can use actually rule-based grant management, right, which is an open source GitHub project, right, to manage these grants. Okay, so what happens is like, for example, in the Snowflake ecosystem, like we integrate with SCIM. So it's an open specification, right, to do automation of user identities and roles in cloud applications using RESTful APIs, right? So this is this is a very typical model of actually how do we do SCIM management of user identities, right? So basically, also in terms of actually permission management. Now, going on to the second part, how do we manage those permissions? Like, for example, right, we have actually, how do we use code to manage it? Or we can actually use an open source tool to deploy them in my first point. So there's actually something called like a Snowflake RBGM, which is a rule-based grant management, right, by James Weekly. And this is actually a open source available tool, right, to actually manage it. There's also Permifrost by GitLab data team, right, for actually these two similar approaches, right? The other way, of course, is that you can have these permissions in Excel file, export the data to Snowflake table, and then use a custom stored procedure to deploy the privileges. Between the two, right, in terms of which approach is more ideal, of course, the second one is a bit more, how should I say, it requires a bit more effort to maintain, yeah? Because you need to create the stored procedure, maintain the stored procedure, deploy the privileges. Whereas you actually integrate with actually the Snowflake RBGM methodology, that's a lot more efficient. That's actually a lot more faster as well, easier to debug things as well. Okay, now we have already talked about, so you can see that from model 1, just let me jump back a few slides. So for model 1, we can see that previously everything is under schema change, manage everything. All my account level objects, schema level objects is all managed by schema change. And now we have transitioned over, you can see that slowly we're breaking out certain things and segregating it. So you can see users and roles, right, we're getting into SCIM, Snowflake to manage. Grants, we're using open source grant management tooling, right, to manage those grants. And the rest of the items, we use schema change to manage it. But this is where also that I want to point out a few things. And let's take a look at these pink boxes, okay? Give me a second. So let's take a look at these pink boxes. The issues which are noted here is that, is schema change really the best way to manage dataset objects? And if you look at, of course, any data warehouse, right, or like, for example, certain data warehouses, right, tables, external tables, views, streams, these are very common objects. Is it really the ideal way to manage these things? That's the question. And traditionally, what happens is that if you use an imperative toolset like schema change to manage it, there's actually huge efforts to actually managing these database objects. So let me just go back in time a little bit just to reference this slide. You can see on the left, right, we need to create multiple folders, right, or multiple files, right, just to track changes, which may not make sense if you're actually trying to scale up. So that's where we say that, okay, why not and easily it takes up at least 70 to even 80% of time when you're doing data engineering, especially when you're talking about incremental data, incremental materialization, incremental changes to my views, to my tables, so on and so forth. And the alternatives here, right, that which I was talking about just now, was that one of it is DBT. I'll show you the DBT console later so that you guys have a better idea. But DBT is here to manage your dataset objects and eliminates the need to actually manage dataset objects manually. Yeah, so that is the benefit that actually it brings to the table to actually help to manage these table changes, if you may. So you can see that right now we are now partitioning it out a bit more, right? We are now trying to refine the model, okay? And this has led us to model tree. Now this option, right, it presents the usage of actually DBT for data transformations, which manages the data sets objects. And then after that, later you use an imperative style tool, right, to manage the other objects like the task stages, file format, so on and so forth, which you use a schema change to do it. And on the left, right, then you have your normal, like for example, SCIM, or even your Snowflake rules-based grant management, for example, to manage the grants. So this is actually a model, right, that actually helps you to manage, especially, remember I was talking about just now, right, in order to manage, let's say, your table, your external table, your views, right, streams, right, all this, it takes a lot of time when you're using schema change. It may not make sense, and it's not really built for that. It wasn't intended for that. So that's where DBT comes in to actually help to fix this particular issue that we're looking at. And of course, here's the alternative of, let's say, option 3. Now, in option 3, just now, we were looking at, like, for example, okay, why not I just use, like, for example, SCIM as well as grants management to manage everything. But now I'm presenting an alternative. Why not we use Telform to do it? So Telform helps to manage. So you can see that basically all the dark blue objects, right, which are actually the account level objects. And these are, to me, are considered infrastructure objects because they're like your base foundation, right? So essentially, we can give it to Telform to manage it. Like you manage the users, manage the roles. The only thing that I want to caution here is that when you're using Telform, right, you need to know a good way to manage state, because state management in Telform isn't, there are certain practices around it, like for example, storing into S3, or maybe if you actually want to track the changes, right, you can definitely put it into, let's say, a DynamoDB. But on top of that, right, you can run on other things like TerraGrant to actually help manage. Well, it helps to, it doesn't really help to manage, but it actually helps to ease the process of using Telform, right? So for Telform, basically, it's being used to actually deploy, manage infrastructure-like objects. It's a declarative toolset, as we discussed just now. And essentially what happens is that with Telform, we can actually manage these items. We outsource the data set objects, your tables, external tables, views, and stream, because as you remember, this is what we're talking about. 70 to 80% of your data engineering efforts, right, are going to be spent here. Incremental changes to your tables, incremental changes to your data, changes in your schema, sudden changes in your stream, sudden changes in your views according to the business justification. And that's where we use DBT to actually help to manage that. And then for your other objects, right, that's where you use, like, for example, a schema change to manage it. So you can see that from option 1, we have actually progressed, right, into actually breaking up and looking into a model, right, that is, or option 3 and option 4, we have seen that actually we are moving from a model, right, that is traditionally just using a single tool to manage everything, now into multiple tool sets to manage the components that is best utilized for. So on this, right, as I mentioned earlier in my presentation when I first started out, there is no single one best available models. Some people prefer to use everything. They prefer just to use for the hassle of it. They don't want to go through too much hassling or manage different tool sets. They just use schema change for everything. That's perfectly fine. Whereas some people, they realize the value of things like DBT, right? Then they use that to actually manage their data set objects as well. Yeah, so there's not really one size fit all to actually all of these environments. I would say there's no one size fit all. But the idea here is that definitely choose a tool, right? As I always advocate, choose a tool that is best suited to actually fit your needs in your data engineering pipeline. Yeah, don't just because you hear Adrian here says that, okay, I need to use DBT for data set objects, I definitely need to use DBT. That's not really the intent of it. The intent of it is to find what best you're comfortable with in terms of your tool sets. Yeah, so this is just a recommended model from my side. What I think is actually what works for me, right? What works for me on a data engineering perspective is definitely between option 3 or option 4 for me personally. So I think one thing that I probably just want to touch upon here, right, as well as on actually just a little bit more deep dive in terms of your dataset objects. And I'll be going into the console later for DBT so that you guys can take a look and understand and appreciate how it works like. Yeah. Just also, I'm not from DBT, but I just find their tooling really interesting. And right now, one of the models that probably we're looking at, right, especially when I interact with different customers and see how to build up these pipelines, is how do we use like things like Kubernetes, right? For those who are on the call and unsure what Kubernetes is actually an orchestration platform, right? That actually helps to deploy and manage your containers, right, in a cluster, all right? So the idea here is that when people, because of the multi-cloud concept, right, people are actually using Kubernetes, right, to actually help manage the container workload, right, across clouds. Yeah. So we know that traditionally with a container like Docker, it's very easy to spin up a container. But how do we manage that state of those containers? That's where actually Kubernetes steps in to help in this picture, right? So with actually Kubernetes, we're able to do certain orchestration to run DBT pipelines. I'm going to let you go through a bit of the DBT console later so that you guys can understand a bit better what's happening and actually to perform dynamic analytics engineering. So you can see that basically from the left to the right, I'm integrating, right, Kubernetes with DBT and as well as actually as GitHub, right, to actually help perform a seamless DevOps principle to deploy changes, let's say, to my Snowflake data warehouse. Again, there's no one size fit all. This is just a model which I find that a lot of data engineers, right, or at least the data engineers whom I'm interacting with, right, they are trying to look at these models. Yeah. So maybe I just go over to my DBT, right, and just to allow you guys to understand a bit better, this is what DBT does. And if we actually go and take a look into, okay, let me just open up my GitHub. Or maybe I can just open up, here. So you can see that this is like the DBT console. There are actually, like, for example, this is where we define our project YAML files. So everything in DBT, right, is written using YAMLs. And basically the key thing here, right, that we are having here is something called, this is where the models are actually are coming up. So you can see, like, for example, right, with actually very simple SQL, I can actually help to change the data or perform data transformations as necessary. Like, for example, here, and the good thing about DBT, for instance, right, is that I can do references to models. I can integrate it with Ginger templates. So if, let's say, I need to do for loops to loop through my data, right, instead of writing code in SQL to do that kind of data, I can just write simple Ginger templates to actually interject into, like, inside my SQL statements. So it makes it easier to actually get the data out. So from this diagram here, from what you see, right, what happens is, like, for instance, we are doing certain transformation, and the transformation is very simple. What happens is that I'm getting certain records from my staging table, staging customers table, and staging orders table, right? And what happens is that I'm actually forming a dim customer table from here. Yeah, that's all in terms of actually what is happening in terms of the DBT console. And as mentioned, right, these models, right, are all written in SQL. So you can see here, right, most of it, in fact, everything is written in SQL. This is what I was talking about, these parentheses, right? We can reference it to, like, for example, different stages. We can actually reference it to different models. Yeah. So, like, for example, this one, I have a staging orders table and a staging payments table, and I'm going to actually create a fax order table from there. Yeah. So again, from here, right, there are actually different ways to actually model the data transformations, essentially. Now, and this is really powerful because when we're talking about incremental changes, we're talking about huge changes on a day-to-day basis, right? It's very troublesome to write lines of code to actually manage it. That's where we leave DBT to actually help to manage this portion. That's what I'm precisely talking about. Just imagine that you have materializations on your tables every day, right? It's going to be a headache just to write the SQL files for that. So that's where this comes into help. Okay, so essentially what happens is that, like, for example, the idea here that we're looking at, right, is that there's a nice linear graph that actually DBT does for you when you do DBT graph. And essentially here, like, for example, what happens here is that you can see that ultimately I want a dim customer table. And I have, this is my source tables. The light green items, right, are my source tables, right? So on the light green tables, I'm actually creating my different models, okay? Different models is like intermediary models here. And then finally, it's going to form into my dim customer table when I want to do certain aggregations or certain analysis on the data. So it makes it really easy for you to do your aggregation analysis, for example. The good thing about DBT as well is that, remember just now I was talking about testing, right? So for actually testing, right, we can actually write test statements as well. Like for example, I can do actually a test statement here, right, that selects and does sum, right, and goodbye having not more than 0, and it will actually do a test for me. So it helps in the process, right, where I'm able to do certain incremental unit tests on the go. Yeah, so I can integrate this all seamlessly, right, inside the DBT console to actually manage it. To actually help to manage this environment, essentially. So the idea here right now is that, okay, coming back to this, right, now we're looking at how do we use, like, for example, a container orchestration platform, such as Kubernetes, right, to help actually manage the incremental changes, let's say, in a data warehouse like Snowflake. And how do we integrate it with, like, DevOps principles? So, for example, here, what I have done, right, is a very simple demo, right? And what I'm going to do, right, is actually deploy my containers, right? What happens is that GitHub will build my containers, build my incremental models that we have here. And anyway, DBT, you can actually sync it to your, basically your GitHub repos. So essentially, when I do a build of my container image, it will take all these models, right? It will take all these models, put it into a container, put it into Docker Hub, and then after that later, it will trigger Kubernetes to run this onto my Snowflake data warehouse. So that's the idea. So that instead of you maybe coming to here to click and then run it, you can integrate it with a container orchestration platform such as K8s. Yeah. So let's just do a quick update here. It's just a mock in any case. So what happens here is that basically I'm just actually, let me show you my full screen. That will be much better. Give me a second. Yeah. Okay, so you can see that actually basically this is I have a local Kubernetes, right, cluster, and you can see that actually there's no pods that are running here, right? There's no resources, what happens. And I'm just going to just do some Git changes, okay, essentially, right? And what happens, right, in the back end, okay, if we go over to actually our GitHub actions is actually just kicking off our changes. So whatever we have here previously, right, inside our DBT console, all these models, right, they're all being packaged into a container, a Docker file. They're all being actually all these models are being packaged into that, and then it's going to be put into GitHub, okay, into Docker Hub, right, as a container image. And then from here, right, what happens is that from there is then going to actually deploy the DBT container, right, onto our platform here, onto our Kubernetes platform. So you can see that right now it's actually building the image, it's updating the image, so on and so forth. And okay, you don't necessarily need to use GitHub Actions. That's my point. But if let's say you're comfortable with like Jenkins, or you're comfortable with things like, for example, Circle CI, right, you can definitely use that to integrate it instead of using GitHub Actions. The only reason why I use GitHub Actions, right, is that it's the easiest so-called demo to set up in this quick span of time, so that's to allow you guys to actually understand. And what happens here is that inside our Snowflake console, right, you can see here is my demo DBT. I don't have anything in my dev schema yet. We are going to fire off all this, right, and it's going to actually apply the implementations, right, from our source data, right, which was customer orders and customers tables, and as well as Stripe, right, into our dev schema. So that's what's going to happen here. And actually, while it's building, right, just for the benefit of time as well, I actually have, so you can see right now it's actually going through the stages, building the image, storing the image, and that is what's happening here. Yeah. On the other hand, actually inside the DBT console, right, if you're using, so there are two ways to deploy DBT, by the way, for those who are unfamiliar. One way to deploy DBT is that you use the public cloud version, which is what you see here. Okay, it's great. You can actually have the lineage graph, so on and so forth. The other way that you can, of course, use it, right, is that if you use the open source model, right, you can use DBT. You can just actually download DBT just using a very simple pip install. And with actually the DBT on the or the open source version, right, you can actually that's how I actually built my containers, essentially using the open source version. So let's do a quick get of my pods, right, just to check. And you can see that right now my pod has run. And actually, if I do a quick logs, right, just to check it, you can see that it has finished running 3 view models and 2 data models. So it has actually computed all this which was what we were talking about. How do I run all these stage models into my customer models, right? How do I actually use dbt to manage it? Now on this, right, if let's say if I go into a Snowflake, right, if I go into my dev schema, for example, we can see that actually the tables are being formed here already. And this is what I was talking about earlier, right? If I go back to my slides here, using actually dbt, right, along with Snowflake, it actually helps you to manage these incremental objects, table, external table, view, and stream, which are, as mentioned again, it takes a really bulk of your time when you're doing your data engineering management. Yeah. So that's the idea. That is what I'm advocating, or well, roughly like advising. And yeah, I think that actually comes to the end of my presentation. I'm a bit early. I'm really about 40 minutes in. And yeah, that's the entire two-step, I would say, in terms of your change management and DevOps. Yeah. So on this, right, maybe I would like to open up the floor to any questions, anything that you guys would like to actually ask. And then after that later, right, happy to actually address any of these questions. Or if you guys have certain things that you guys want to discuss with me, we can always, you can put it in the chat. All right. I think, Lawrence, if I'm not wrong, right, they can just write in the chat, in the comment section, and then post it back here, right? If I'm not wrong. So feel free to do so, and we can address those questions.
Yes, Adrian, you're right. So if anyone, if you guys have any question for Adrian, please feel free to actually post your questions on the comment section, and then we'll address it accordingly. Yeah.
Yep, thanks for that, Adrian. Let's see if there's
Yep.
any question. I have one question in mind though. Let's see whether the community has any
Sure.
question for you. Yeah. Okay. Maybe while waiting, I'll just ask. If for example, some of my data is not actually in databases or warehouses, it's actually file based. Can I also use the dbt approach to govern the change? Yeah.
Okay, so for dbt works very specifically, right, with mainly on data warehouses. Like it works with Snowflake, works like on BigQuery, Redshift, for example. For incremental file changes, if we're talking about like unstructured data like CSV files, flat files, for example, I don't think it manages that. I have to double check. I don't think it manages. The last time when I tried it, I don't think it does it. But more of it actually manages the warehouse state. Because we have to look at the whole intent of what dbt does. The whole intent of actually dbt, right? Maybe if I just go into the screen share a little bit so that you guys can understand a bit better. So if we take a look here, right, the whole intent of actually dbt, right, it actually helps to transform data, and it does analytical and engineering specifically. So the whole idea is that when data is in your warehouse, right, when the ingested raw data is in your warehouse, that's where you use dbt to help to do your modeling, your testing, your development, and this is what it is. It's good at. Yeah.
Okay.
So for those who are actually unsure as well, there's a pretty good fundamentals on dbt. All right. That is a free. It's a free course. I set for it. It's pretty interesting, and you guys can actually learn how you guys are using how dbt works basically in this aspect. Yeah.
Okay.
Correct.
Okay. I see. Okay. Thanks for answering that. Okay.
Yep. No worries.
Don't see questions yet. Okay. So this model of yours, this whole tool chain, right? Has it been used by any customers? Have you seen some real world examples of parts of it? Yeah.
Okay, so I think one thing to say is that a lot of customers, right, especially in the engineering pipelines, they are using a lot of dbt. Quite a number of them are using dbt to actually help to do the analytics engineering pretty well. Of course,
Okay.
the data, right, because they store it into Snowflake, is quite seamless there. They just store it there, have the data there, and with the data sharing stuff that you can do on Snowflake, right, it actually helps to ease the entire experience of actually sharing out data and as well having data inside your warehouse. So, but in terms of the pipeline, I would say that it varies from customer to customer. Some customers, right, or some people, right, they prefer to run everything on dbt. Like I mentioned just now, they do the transformation using dbt. Some, on the other hand, they use like Python to do it. Some, on the other hand, they integrate it with like things like Airflow, like Apache Airflow, right, to actually do the orchestrations. Like for instance, right, that K8 diagram which I showed you just now, you can achieve it more than one ways. There's not a necessity to use Kubernetes. You can definitely use things like Airflow to actually help manage that portion. The Kubernetes portion is just like a side. It's like by the way discussion lah. Like if you guys are really comfortable with Kubernetes, then of course it's much easier to deploy stuff on K8 because you may be familiar with it. So that was a long answer, but the straightforward answer to your question, right, Tichun, is that basically I think it depends from person to person, engineering organization to engineering organization. Some things would definitely use some would definitely use DPT, some don't. And then after that later, but the whole idea, right, is that at the end of the day, they want to store the data. They want to actually get the best use of their warehouse and use the resources in their warehouse, in their data warehouse. That's the idea. Yeah.
Okay.
Please share the Python application on Android phone so that easy for developer. Are you asking to share what Python application? Sorry. I mean, can you elaborate a little bit more? Yeah, because I'm not very sure what Python application you're talking about. Bala, yeah.
Yeah.
Okay. Maybe Bala, you're away for now, but no issues. If you want, you can definitely Slack me a message or you LinkedIn. Then after later, I can share with you what I have done. Developer cases. Okay. Please share the Python application on Android 4. Actually, Bala, I mean, if you like, right, we can definitely have an offline discussion so that I can understand a bit better what kind of developer cases you're looking at. Then after that later we can work towards that. Yeah. Yeah. Anyway, by the way, Tichuan, are we making these slides available or anything for the public?
Yeah, so the YouTube channel will always be there, so they can re-watch the recording. Yeah, so at any time, which is also on the LinkedIn, which is on the Meetup.com page where you sign up for. So the link is there; it's always permanent. For slide-wise, we can share that link, which is on the Google Docs, right? That you share. So maybe you can repost it in the private chat while we make it more public in the YouTube channel. Yeah, you don't mind. Yeah.
Can.
Do it.
I probably just need to do a bit of sanitization on my deck. Then after that later, I can post this session lah. Yeah, so that then I know there's been quite a lot of content we went through. So not everyone may have grasped everything. And I understand that lah. Yeah.
Okay. No problem. Yeah, I can also help the broadcast in the Meetup.com.
Got it.
Page.
Understand.
Yeah. Can. All right. Let's see. Any other comments? Okay. Maybe we should talk to Bala offline. Right? Yeah, to understand his questions better. Okay.
Yeah. Correct.
Okay. No problem, Bala. We touch base. Yeah.
Can touch base on that.
Yeah. Okay. Let's wait a while for 1 more minute, maybe, for any other questions. Yeah. So I think we welcome you back again, Adrian. Anytime that you want to present further topics. Yeah, and also if your peers wants to also present on this data engineering related matters, please help to do so.
Sure. Anyway, I'd like to thank Lawrence and thank Lawrence, Teck Chun, and as well as Barbie, right, for actually having me on this session today. Happy to be presenting. It was a very good session lah. Yeah.
Thank you. Yeah. So okay, I think there might be no There might be no
questions.
no questions. Yep, I think so.
Okay.
Okay, with that, I
In
think
case you guys can definitely LinkedIn me as well.
Yeah.
And then and then after that later, if you have anything, you can just chat me there.
yeah. You want to post a LinkedIn link
Oh, yeah.
again? I will broadcast to the channel. Yeah.
Yeah, let me just write that. Let me just put in the comment section for those. Oh, I cannot put in the comment section. Oh, maybe
Yeah,
I'm
also
private
can.
chat with.
Yeah, also can. Well, I do that for you.
Thank
Let
you.
me-
Thank you.
Yeah, no problem. Okay, can. All right, with that, I think we've come to the end of today's meetup. Thank you, Adrian, for spending time with us this evening on this topic, right? And
Yep.
for the rest who tuned in, thank you very much for also spending an hour and plus with us. Right? Hope to see you again soon, and we have more topics upcoming months. Right? Working with Google developer spaces. Okay.
Sounds great.
Yeah.
Right.
Thank you, guys.
Thank you.
And that's all. Right. Good evening and stay safe. Bye bye.
Bye bye.